All right. All right. Welcome to carbon and carbon dioxide. Here's the attention getter. Whoa. And look, there's carbon dioxide right there, and the whiteness there. That's carbon dioxide. And that's one of the experiments I'm going to do today. So I'm going to pull that out of there. CO2 cartridge. So, what we're going to learn today is what is carbon and what is carbon dioxide. We're going to learn about the carbon cycle, the fast cycle and the slow cycle. It takes millions of years. And how humans are part of that carbon cycle. So, why are we learning this? Why is this important? This is important because humans are changing the earth. And specifically, for this discussion, global warming. And we have heard again and again that carbon dioxide creates global warming. Carbon, what is this carbon stuff? Carbon, element number 6. Here's some soot from my wood stove. Be very careful with this because it doesn't clean up. It's really black carbon soot. That's pure carbon. It doesn't have a chance to mix with hydrogen or oxygen. It's pure stuff. And these candles that are burning, they're petroleum oil that has been condensed, and it's burning the carbon and releasing the light. So what is this stuff called carbon dioxide? Here's one common experiment. Arm & Hammer baking soda and some vinegar. Oh, hope I didn't do so much. And another experiment is a bubbly soda. I'm going to let that cool. Now, the carbon dioxide is collected in here. Now watch as I pour the invisible gas and it put out the candle. And now I try the invisible gas from the soda pop. I'm not going to pour water. Just the top of, come on, get in there, get in there. Oh, it didn't help, but it helped. Oh, this is a lot of carbon dioxide there. Let me try again with this. Get that carbon dioxide out of that air. Oh, it dimmed it, but it didn't go out. So, carbon dioxide is in this stuff. And the carbon dioxide in that canister went from 41 grams to 30 grams. So the full canister is 41 and the empty canister is 30. Hey, they said 12 grams, but it had 11 grams in it. It was real stuff. It had real mass. Now, my next little demonstration is trying to understand that we produce carbon dioxide. It's just like burning a candle. We are burning our food. Here's a box of rice. Now, this is about 2 pounds of rice. If you ate only rice, this is about 3,000 calories, and this is about how much you have to eat every day just to survive and keep alive, if that's all you had to eat. Now, you burn this rice, and every breath you take, you exhale 2 grains of rice. Now, if you were in my classroom, each of you would have a dish of rice. And every time you exhale, you put 2 grams of rice in there. 2 grains of rice. 2 grains of rice is about what we exhale in carbon dioxide in each breath. I continued through this whole box, I would go through this whole container in the day, and I'd turn all this rice into carbon dioxide at about 2 pounds, a kilogram per day. I'm going to switch over to metric, a kilogram per day. A kilogram per day means 365 kilograms per year, about a third of a ton. Oh, tons? Let's take a little sidebar and talk about tons. 1 English ton is 2,000 pounds. 1 metric ton is 1,000 kilograms, or 2,205 pounds. It's pretty close in quantity. They're close enough to say you need a big truck to carry a ton. So, 1 billion tons equals a gigaton. When I first started studying this, I saw this referenced different ways. 1 billion and a giga are the same thing. Now, if a human exhales 1/3 of a ton per year, and there's 7.8 billion of us, that means that we exhale 2.6 gigatons. 2 billion tons. Either way, you can look at it either way, it doesn't really matter. But we, at least 2.5 billion, 2.5 gigatons. So that's the quantity that we can think about. We are a significant part of the natural cycle. The cycle has, this is the carbon cycle. Air, land, ocean, and these cycling from photosynthesis down and we eat it, photosynthesis down and it exhausts back up. These are the natural fast cycles that we're part of. All that 2.5 gigatons is in this fast cycle, and we are feeding the plants and they're feeding us. And some of it drips down into a fossil fuels if the conditions are just right, or it goes down the sediments at a rate of about 0.01 gigatons per year. It's just a little dribble, and so that's called the slow cycle. And it might come back up with a burp in the volcanoes, but it's generally downward, and we've stored all these things down. Now looking at some quantities. Now remember that 2.5 gigatons that humans produce. This is how much is in the air. 760 gigatons. Natural respiration and photosynthesis does 120. We're 2 of that. We're 2 gigatons of the 120. And all this land and biomass accumulates. Actually, it's mostly trees and soil organic. And the ocean has a natural cycle. Photosynthesis and exhaust. And it dribbles down in sediments. However, people have gone down into the slow cycle and are pulling 1 extra gigabyte from the land by changing the land. They're pulling 7 extra gigabytes from the fuels and 1 extra gigabyte from the sediments. That's mostly in cement. So, to simplify again, the air, the land, and the ocean, natural balance. But we have disrupted this by pulling 7 gigatons from the fossil fuels every year. 1 gigaton from the land every year by burning the forest and changing to something else that doesn't store the carbon. Luckily, we haven't disrupted the ocean system as we know yet. I'm sure the temperature and the acidification is a problem. So these 3 inputs equals about 9 extra gigatons we're adding. This is not an unmanageable amount, it's a lot. Here's some solid proof, solid, irrefutable scientific evidence. In the Mauna Loa volcano, Hawaii, and elsewhere in the world, they've replicated this experiment many times to show that carbon dioxide in the air is increasing. And in 1960, it was about 350 gigatons in the air. Now it's 760 gigatons in a year. It's that 7 or 8 or 9 gigatons a year that we're adding. adding it into the air. Irrefutable evidence, and the evidence is that carbon dioxide causes exacerbates global warming. So, what you learned: carbon dioxide is a real thing. We can't taste it, or feel it, but it's real. It has mass. And we are part of the carbon cycle. We're naturally part of the slow cycle with plants, but we're dipping into that slow cycle. We're in the fast cycle with plants, but we're dipping into that slow cycle that should take millions and millions of years. We are pulling carbon from the deep pools. That's the big problem, and that's what we have to address to change our global warming. Now, let's see if I can end with a good finish here. Let's see. Which one's... Okay. Let's look at some carbon dioxide again. 5, 4, 3. Come on, where is it? 2, 1. We want to do this. There it is. And there.